What makes reusable rocket stages like Falcon 9 land with such precision? Imagine a rocket returning from space and landing vertically on a tiny platform in the ocean or on a ground pad, all without crashing. How does it do that? Well, it all comes down to smart engineering and precise control. When the first stage separates after launch, it doesn't just fall back to Earth. Instead, it performs a series of carefully timed maneuvers to guide itself back safely. First, it fires its engines in a boostback burn, which reverses its path and points it toward the landing zone. This burn is like steering a car to make sure it's on the right track. Then, as it re-enters the atmosphere, it does a re-entry burn to slow down and reduce heating from the friction of passing through the air. This burn helps keep the booster safe from damage and keeps its descent controlled. As it gets closer to the ground, a final landing burn slows it down even more, so it touches down softly and vertically. What makes this possible are several key features. The Falcon 9 booster has 9 Merlin engines that can be throttled, meaning they can control how much power they produce. This allows the rocket to adjust its speed during descent. It also has extendable landing legs that deploy just before touchdown, giving the booster stability on the ground. Near the top of the rocket, there are grid fins, movable surfaces that act like airplane control surfaces, helping steer the booster during its fall through the atmosphere. Inside, onboard sensors and advanced navigation systems constantly track the rocket's position and orientation, making real-time adjustments. All these actions are managed by sophisticated flight computers that process data and command the engines and fins instantly. This combination of engine control, aerodynamic steering, and precise timing allows the Falcon 9 to land within meters of its target, whether on a drone ship at sea or a landing pad on land. Achieving such accuracy is a huge engineering feat because the booster faces extreme conditions during re-entry, including high heat and aerodynamic stress. It must survive these challenges and stay on course without the lift that an airplane would have. Thanks to these innovations, SpaceX can recover and reuse the most expensive parts of the rocket, making space travel more affordable and sustainable. This success paves the way for future rockets to be fully reusable, like the Starship, which aims to reuse both stages for even greater efficiency.